Ever tried to cook a massive holiday dinner entirely by yourself? You have 6 pots on the stove, a turkey in the oven, and you're frantically flipping through a recipe book, trying to remember if you already added the salt. It is completely overwhelming to keep track of every single step. Your computer's processor faces that same sense of overwhelm every time you give it a command, whether you're asking it to solve a math equation or just double-clicking to open an app. The processor doesn't actually speak our language. Before it can do anything, your command has to be translated into assembly language, a specialized shorthand that acts like a simplified code for professional chefs. This visual breakdown shows a human command, adding X and Y, being simplified. At the bottom, we see the machine code. These ones and zeros are the raw electrical signals that function as the exact physical muscle movements the hardware needs to perform. So how does the processor execute millions of these tiny electrical fluxes in perfect order without crashing or losing its place in the recipe? Computers rely entirely on a rigid, flawless mechanical routine. Their power comes from translating and executing those tiny steps over and over again with perfect precision. This diagram shows how the routine is organized. The central processing unit is the active workspace. Below, primary storage functions as a pantry. Because it can't memorize everything, the processor uses registers as temporary sticky notes for immediate use. The first sticky note is the program counter, or PC. This acts like a chef's finger, pointing firmly at the specific line they are currently reading. Next is the memory address register, the MAR. When the chef needs an ingredient, they use this to write down the exact aisle and shelf number to visit in the pantry. Then there is the memory data register, or MDR. If the MAR is the shelf number, the MDR represents the chef's physical hands, holding the actual box of ingredients they just pulled. Without this hierarchy of registers acting as short-term memory, the processor would instantly lose its place in the millions of instructions it must execute. During fetch, the system uses the PC, MAR, and MDR to retrieve instructions. In decode, the control unit interprets the action. Next, the execute phase uses the ALU to perform the calculations. Finally, store saves the finished result to memory. Once stored, the program counter finger advances to the next line of the recipe. This instantly triggers the entire cycle to start all over again. Every action a computer takes, from basic math to rendering 3D graphics, is built by repeating these same 4 mechanical steps. Imagine our chef performing this basic loop faster and faster, accelerating until their physical movements become a high-speed blur. Modern processors complete this exact fetch, decode, execute, and store cycle billions of times every single second. This speed is what allows the computer to handle massive amounts of data in the blink of an eye. When you stack billions of these simple add and store steps on top of each other, they transform from basic math into the complex logic that powers everything from photo filters to artificial intelligence. Strip away the sleek screens and complex software, and you find a digital chef following a recipe, one fetch at a time.